We now move to our second project. It's called Emotion Detection and Analysis, a web application which will create a report for audience reactions to help public speakers improve their speech. I think this is of particular interest to me, given that I'm being brought to the forefront and into the limelight to be doing these sessions. But over to Aamir, Himani, Ibtisam, and Rohit.
Thank you, Bhavna and Univ, for giving us this opportunity. And we'll just share a screen and start. You can start.
Hello, everyone. Yeah. Hello, everyone. We are the Mystic Forces. Our team comprises of Aamir, Himani, that's me, and Ibtisam. And we bring to you EDAA. EDAA stands for Emotion Detection and Analysis. Remember the first time you had to give a presentation? Do you remember how nervous you were? Did you shiver with the fear? Did you wish you could read minds just to know what to say to satisfy your audience? Didn't you wish there was an application that could give you statistics about your audience's behavior? Don't you worry, my friend, because your prayers have been answered and EDAA is here to your rescue.
So what is EDAA and what's our vision? EDAA is meant to be a smart web app which could be coupled with our meeting application to gain real-time meeting analysis and receive live feedback in the form of report by taking into consideration facial expressions of the audience and the context of their speech. The models we have used are YOLO. It's our facial emotion recognition model and was trained on subset of AffectNet. Then for speech, we converted it into text using OpenAI's Whisper. For sentiment analysis, we use SentenceBird. And for Techstack, we use TensorFlow and PyTorch as our framework. GitHub was used as our source control. We containerized all our apps using Docker. And for communication between these apps, we used Fast API as for developing our RESTful API. Then React was used for our front end. We will be scaling using Kubernetes and we deployed it on GCP for GCP. These are the libraries we used in our project. The web architecture. The user uploads a video into the front end, and the front end sends it to the preprocessor API. The API splits into two chunks, the audio and the video chunks. The audio chunks are read by Whisper container, which generates text chunks. These text chunks are read by SBird container, and it generates the analysis. These analyses are sent to the GCS bucket. And on the other end, we have video chunks. These are read by GCS bucket and are sent to the YOLO container directly from the GCS bucket. The YOLO container then gives us the video predictions. These predictions are again sent to the GCS bucket, which in turn gives us the final results, which are sent to the React front end, and then it gives it to the user. Now we will go to the EDAA demo.
Thank you, Tizam. So now we move to the EDAA demo. Now, here we can see this is our web application, EDAA, that is Emotion Detection and Analysis. To start analyzing your videos, you just have to go, say, get started, and it will bring you to this section where you just have to input your email and click on choose file to choose whichever video you want an analysis on. Then click open and hit submit. We will be skipping this part because videos take a while to process. Hence, we also have some pre-processed results for you in the My Videos section. So let's go to the My Videos section. And here we can see we have some pre-processed results for you. Let's have a look on this video. So the first thing is the name of the video. And the second is you have a links to the report of the analysis that is generated by EDAA. So this video is, my guy Tony is here on the top right block, and he is giving an interview, right? So it would have been so wonderful for him if he had these analysis on real time. But anyways, let's see what EDAA generated for it. When you click on review results, it will take you to this page, and here are the results. On the top, we have the metadata of the video. Then we come down to image sentiment analysis portion, where on the left, there is a bar graph that shows the frequency of the overall reactions in the entire video. So we have three generic reactions, we have coupled many emotions into these three categories, that is positive, negative, and neutral. On the left hand side, you can see there's a time series graph that displays the frequency of the reactions received in an interval, and we have chunked the videos in a 10-second interval. So for instance, in the first 10 seconds, how many reactions you received are positive, negative, or neutral. And you can see that John has get the peak results of positive reactions in the 50th to the 60th second. So this will help our user to know what thing have worked for them and what didn't and when. So now moving to a speech sentiment analysis portion. Here we provide you tables that contain the sentences that have received the highest engagement corresponding to their respective classes. For instance, we take positive class here, and in the 50 to 60th second interval time frame, John said this sentence and he received 8 reactions from his audience, and this helps him to understand that his interviewers were happy with this sentence and what he said. So these tables can be read in a similar fashion for the other classes like negative and neutral responses as well. And this is basically what EDAA generates as a report. So thank you so much. This is our web app, and we are now open for questions. Hello.
All right, thank you, team.
Yeah.
Did you ever put any of the lectures through this?
Can you repeat that, Pablo?
Have you ever analyzed any of the lectures of us?
We were thinking like, but the video would have been really big. So we
taken
want to
a
scale it.
long
Yeah.
time. And
That would
be kind of fun.
Professor,
Which part did everybody become neutral on?
Say again, Rahul, can you repeat?
Which part did everybody become neutral on? That means everybody went to sleep or something like that.
Professor will let you know once we do that.
Yeah.
We did put a video once of a meeting we had, our Professor Shivas. It's not in the top 3 right now, but we did do that. And it's nice to see.
I think, yeah, we presented it to Shivas that
But
time.
I really think it would be a valuable thing if you move the plugin for Zoom and it gives me a warning. They're falling asleep. Do something. Dance now.
Yes, that is our next step, like to create plugins for the web applications like Zoom, Google Meet, and like Microsoft Teams as well. Yeah.
Are you actually thinking to move it forward and commercialize this?
Yes, maybe. Yeah.
I definitely think we need to look for some VCs for this for this one. I had a question about how. So right now, if I understand, the architecture is more along the lines of you submit the entire video with a certain number of frames.
Yeah.
And it will do an analysis for you and give you this time series over a series of time. So one question I had was, what is the latency of response on this thing? And if I therefore wanted to sort of like give Pavlos an almost real-time notion of how boring he was, how would I be able to do that?
It actually depends upon the hardware we have. We are running it on GCP, so we are using the highest number of cores we can get there. 24 cores virtual machine. We aren't getting used there, so it takes almost.
So the inference is all on CPU right now.
Yes. It takes almost 4 minutes or 5 minutes. I mean, it depends upon the video length, actually.
So if those models you have, the Whisper and the Spirit, are they the full-fledged, or are you trying to compress them, distill them by any chance?
No, we haven't performed distillation yet. So they are full-fledged models at the moment, but when we will try to make it a real time, so that is where we'll try distillation in them, because they are fairly big models with large number of parameters. And if we have to make it real time, so the model should be, less. It should be concise a little than it is already.
Yeah, and mainly YOLO takes some time because it is predicting on the pictures, but it can do it in real time, but it needs some more fine tuning.
Right. And so, I mean, if I give you a 1-minute video of me, it will take how long?
4-5 minutes at maximum.
Yes.
Okay, so that means that, and there is no sort of auto-regressive aspect to this, right? In the sense that I could chunk my 1 minute video into 10 6 minutes, like a 6 second, or maybe, or is that too little a time to get the emotion out? Or, I'm trying to understand. Could I chunk it into 6 10-minute sections and then set it to 6 different container sets running on Kubernetes somewhere? How would I scale it is what I'm sort of, I suppose, asking.
It would take your entire video, even if it was 6 or 10 minutes, right? So video chunks will be created right here, and these chunks frame wise will go to GCS bucket, and you do not have to give it to different set of containers. The one we'll store it in the storage, GCS storage, and from the GCS storage, it will corresponding to the video name or the key that we are providing. YOLO will fetch them and do the analysis right away on the whole video. It does not matter if it is 10 minutes long or 20 minutes long. So we have the chunks, so it will do the analysis on the whole video, and we'll get the result for the whole video.
Got it.
Yeah.
Okay, one more questions, not from by the way, Rahul, your video I can quickly answer. Boring. From anywhere, from anyone else besides me and Rahul. Oh, Jess. Go ahead, please.
Can you hear me?
Yes. We can't see you, but we can hear you.
Now?
Yes, perfect.
Yeah. So I had a question. Why are we using text prediction? Isn't this based on the human emotions captured by the camera?
So, Ojas, it is on the human facial expressions as well as the sentiment of the text, which the user is speaking. So, for example, if this is the meeting going on and I'm speaking at the moment, it will tell you exactly when Himani, you were speaking this sentence, these many people were happy or positive, feeling positive, these many were feeling negative. That is the whole point. So you can tweak it in such a manner that the negative ones go to neutral or to positive.
So let's say I'm speaking a negative sentence and the emotion is also negative, which means my whatever I want to convey is being conveyed, right?
Can you repeat that, Ojas?
So you said we are analyzing the text for the emotion of the text. And also we are recognizing the facial expressions of the people out there.
Yeah.
So we want to check whether what expression that we want to, like what impression we want to have on people is being had on that people or not, right?
Yes.
So are we also providing an analysis of that? Like, are you also providing that?
Yes, I think the tables do that, right? So you let me understand your question properly. So your question is, if you said a negative sentence and it is predicted as negative, so can you see the reactions of the people on that, right? Is that your question?
Yeah. Are the people's reaction in sync with the sentence that I speak?
Yes.
Oh, yeah, that is, yeah. Like if you have said a sentence in 10 seconds, right? That you are doing this and you've spoken a sentence in a 10-second window, right? So all the reactions are in sync with those like the reports are in sync with with that sentence. So we have created the data structure in the backend that way that everything go in sync with the time series we have.
I didn't mean in a way of actually setting the clock. I mean, like I want to have a positive impact on my audience, and is the positive impact being had on the audience, or are you checking that as well? Like, is the purpose of analyzing text that?
So the purpose is to figure out, I mean, we cannot always have positive responses from every meeting, from every sentence. So the point is not for us to convert it to a positive response. It's just showing the analytics so that the user knows what type of impact it is creating on the audience.